Now let's do the machine learning. First thing we need to do is to split the data into X and Y. Okay, do a new text header for that. Split data into X and Y. We can say Y, it's for machine learning. Okay, shift enter. So this is standard. We're taking the last column is the Y. That's what we're trying to predict. And X is everything else. So X is df.iloc, all rows, start at the 0th column, go all the way up to, but excluding the last one. Okay. Y equals df.iloc, index location. Same deal, we want all the rows, but only the last column. So these two complement each other to include all the columns in sum. Okay, and you can always check these, you know, you can check them in a lot of different ways. You could try df.shape. Okay, 94 columns, and you see the number of rows. X.shape, 93 columns, same number of rows, and Y.shape. And when what the, right, that looks confusing, but it does mean like, see, it doesn't think of it as a column because it's like a series, but it does mean like one. Okay, so it's good. And if you know you're ever in doubt, just check it, right? You could just type in Y. What do you get? Zeros and ones, right? That's what we're looking for. Okay. Okay, so we've split the data into X and Y. Now we're ready to do logistic regression. Now, before doing this, it is critical to emphasize why we are using logistic regression and not, say, linear regression. It's because what we are trying to predict, this output, has all these zeros and ones, right? You don't want a regression line for that. You want things that are going to all go to 0 or 1, and that's what logistic regression is made for. So you have to know your target column, know what you're trying to predict, understand its variation, and whenever you have all zeros and ones, it's a clear-cut case, logistic regression or another classifier. Okay, so let's do logistic regression now together. So build logistic regression model. All right. It's exciting, right? I mean, this is a machine learning model. Okay, it's a nice one. All right, so how do we do that? Well, it's same steps. First, we need to import it from sklearn.linear model import logistic regression. Great. And then we want to do initialize the model. I'm going to write it in since our first time with this. So number one, import logistic regression. I'm going to do a generic though. Let's say import model. That way, you know, the steps are the same. Two, what we need to do now is initialize model. So remember how to do that? Well, if model is what we're initializing, you put model in there equals, and then that's what we imported, right? We got to use it. So logistic regression. Great. Now, number three, we fit the model. Now, there may be an issue here, and we'll come back to it. Model.fit, and then it's always X, capital X, comma Y, assuming you've set things up correctly. And finally, we want to see how we did, so we do want to score the model. Model.score X, comma Y. And by the way, here the scoring is clearly the percentage correct. Okay. So everything's going to 0 or 1. If you got 95% correct, score will be 95. There's a lot of rows here, so we'll see. Okay, let's run it. And it worked. Great. So it got 80% correct. Good. Now, the issue didn't arise, but I do want to mention it because it does sometimes arise when you do logistic regression. It can fail to converge. Okay? So let me show you the difference. Just copy this in. So that's what I'm going to say. If model fails to converge, use max iter. And that's the maximum number of iterations. So sometimes by default it's not high enough. Maybe they changed. I was getting errors with this a lot. And I'm just trying to keep it a little concise here in the coding cell. So here's where you would put it, max iter. You can use it anyways. And I forget, I think it's a little too low. 5,000 should definitely be sufficient. It'll stop if it, peaks out, but sometimes it doesn't find the minimum and it stops, it terminates, and your score is not very good. So you can see it's the exact same score. Okay. So this is just like an aside note that may come up on occasion. Okay. What goes inside the parentheses, by the way, of machine learning model are a lot of things. Okay. That's basically all there is to logistic regression, right? I think what we want to, there's a lot here to try to put in to like predict it, but let's just try this. If I do model top predict, let's say I pick, I don't know. Can we do the last 5 rows? Let's try that. Let's try just the last 5 rows. Okay, so it's model.predict. And then what am I going to predict in parentheses? Well, it's an X, okay? Right, so X bracket what, right? X is like its own df here. Well, for last 5 rows, you want to start at the -5th and go all the way, right? Can I count? I think that's right. Let's just see. And you can see what it gives. And we can compare that to, by the way, y.tail, which will give the actual last 5 rows. And you can see it missed one of them. And that's fitting, right? Because, what is it? It's fitting because it gave 80%. So in like a random 5, you would expect that it'll get 4 out of 5 correct, which it did here. Okay? So there's an introduction to logistic regression using code.